Hello there. In my previous video, I went over the absolute value function and how to define it. Really quickly, I'm going to go ahead and write that off to the side here. The f of x equals the absolute value of x is defined as what's called a piecewise function. Again, a concept I will go over more in future videos, but it just means the function is defined by separate pieces. As x, if x is greater than or equal to 0, and negative x if x is less than 0. And this definition is going to play a key role in how we solve absolute value equations, the main purpose of today's video. So I've got three problems for you. My first one is the absolute value of x minus 3 equals 5. Now, I'm not going to get too crazy with it today. I'm just going to go over three examples. They're all pretty basic and straightforward. Now, because of the way the definition is set up into its different pieces, we have to account for the fact that we could be dealing with, and if I just sketch this graph really quickly, the x minus 3 would look something like this, and the y equals 5, or this 5 on the other side, would be a horizontal line. And I'll leave you to verify that that's the case. We can see it's going to have two different intersections. And now this is a very rough estimate. These aren't where the points are going to fall, but nevertheless, we would have two intersecting points. And look at, one is going to be intersecting the negative part of the graph, the quote-unquote negative part of the graph, and the other one is going to be intersecting the quote-unquote positive part of the graph. It's for this reason that when we solve absolute value equations, it is traditional that we set up two different equations to solve. So when you see an absolute value equation, you're probably going to be solving two distinct equations. So the first one is to just drop the absolute value. We get x minus 3 equals 5. That's the first equation we need to set up. The second equation, and I'll write or, is to set up the negative of x minus 3 equals 5. Okay? Now this first one's pretty straightforward. I'll add 3 to both sides, and we get x equals 8. And we can plug that back in. If we plug it back in here, we have 8 minus 3 is 5, and the absolute value of 5 is 5. Okay. Now for this one, we can do one of two things. We can divide by this negative, or we can distribute it. I'm just going to go ahead and distribute it. We get negative x plus 3 equals 5, and then we'll go ahead and subtract 3. We get negative x equals 2. And if negative x equals 2, then it stands to reason that x equals negative 2. We can always solve that by dividing both sides by negative 1. Okay, this is great. If we can plug this again back in, negative 2 minus 3 would be a negative 2 plus a negative 3, so that'd give me negative 5. And the absolute value of negative 5 is 5. Okay. So now, really quickly, I'm going to caveat that with, sometimes people take this negative, and instead of setting it up with the x minus 3, they save themselves a little bit of time. Remember I said we could divide by negative 1. So you could just drop the absolute value, make this another x minus 3, and set it equal to negative 5, in which case add 3, negative 5 plus 3 is negative 2. So that's an alternate way to solve for it. Okay, but 8, negative 2, and we checked our answers, so we're good. Let's go ahead and look at the next one. So let's go ahead and set it up. Dropping the absolute value, I get negative 2x plus 3 equals negative 6. And then we're going to go ahead and take, I'm going to actually try the other version where I just drop the absolute value, negative 2x plus 3, and set it equal to a negative of a negative 6, which would be positive 6. Okay, so I'm going to go ahead and subtract 3 from both sides. And this is nice because I can solve these simultaneously. We can see if I set it up this way, I'm doing minus 3 as my first step for both of them. So I get negative 2x equals negative 6 minus 3 is negative 9. And then over here, I get negative 2x equals 6 minus 3, which is 3. And then we'll go ahead and we can see once again, I'm dividing by negative 2. Okay, I get This cancels, x equals negative over a negative, that's a positive, and it doesn't simplify, so 9 halves, and then x equals a negative 3 halves. Okay, let's go ahead and check these really quickly. So let's plug it back into x once again. We get negative 2 times the 9 halves. Well, the 2's would cancel, and we get negative 9 out of it, and we get negative 9 plus 3. So I'll just write that is 9 plus 3 is negative 6. Ooh, that's promising. Absolute value of negative 6 would give us positive 6. And we don't wind up with negative 6. Well, surely we didn't do all that work for nothing. Let's go ahead and plug in the negative 3 halves. So 2 times the negative 3 halves. So the negatives would cancel. You get 3 halves times 2, and the 2's would cancel. So you get 3 plus 3, so I'll write that down here, equals 6, and you still wouldn't get negative 6. Now, some of you may have been screaming from the very start not to go down this route. I wanted to show you why, especially, I don't check my answers a whole lot. I'm just going to be straight with you. I'm a person who I take my answer and I run with it. Now, that's to my detriment sometimes. But I showed this to you because this is the one time I definitely will check my answers. We started with an equation, an absolute value equation equal to a negative number. If there's one thing we always have to remember about absolute value is unless you're plugging in 0, you're going to get a positive result. So it goes to show you we have no solution for this equation. If you wanted to go ahead and check it, you would see that when you graph both of these separately, you would get no intersection points at all. I show this to you just to simply point out that if you ever lose sight of this idea, the algebra will always work out. You can still do this entire process and this entire process, and it won't mess with it at all. You'll be fine. But at the end of the day, you're left with still no solutions, and then these things that you're presenting as your solutions are no good. Okay, so let's do one more example. Absolute value of 2x plus 1 minus 3 equals negative 2. So this has to be a no solution, right? I went over an example where we have an absolute value equal to a negative had no solution, and that should always be the case, unless we have something that exists outside of the absolute value that could mess with that reality. Let's go ahead and take care of this 3 and see what we really end up with. So I'll go ahead and add 3 to both sides. I get absolute value of 2x plus 1 equal to negative 2 plus 3 is a positive 1. We're good to go ahead and solve this. And we wouldn't set up the positive negative alterations of the positive negative alterations of this equation until we have the absolute value by itself on one side of the equation. So I get 2x plus 1, just set it up as normal without the absolute value, and then the other form would be 2x plus 1 equals negative 1. Drop the absolute value, make the number on the other side negative. And this is okay because we've dropped the absolute value. When we apply it, this would turn back into a positive 1. Okay, so we'll subtract 1. One more time. And I'll do that over here too. And we get 2x. Well, that cancels and that cancels, so we get 0. So it's not hard to see x equals 0 from this one. We get 2x equals negative 1 minus 1. That's a negative 2. I divide by 2. I get x equals negative 1. Let's go ahead and plug that back into the original equation. So I'm plugging it in here. I've got 0 in here. 2 times 0 is 0. Plus 1, well, that'd be 1. The absolute value of 1 is 1. And then I get 1 minus 3 equals negative 2. So we're good. Okay, x equals negative 1. Again, we plug it in here. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Then we take the absolute value of negative 1. Negative 1 has an absolute value of 1. Minus 3, again, gives me negative 2. That's all I got for you today. Thanks for watching.